And welcome to today's lesson. In this first tutorial, we are going to begin an introduction on the graph of cosecant and secant functions, and we will also start to explore the domain and range. So let's flip on over to this. We are in the second half of section 5.5 in our textbooks, and we're going to be graphing the cosecant graph and the secant graph. To graph the cosecant graph, we have to understand that it is the reciprocal of the sine function. So really we need to be able to graph the sine function first. So this is a nice review of graphing sines and cosines today. I'm going to do my normal scales. So my fourth tick mark will be pi, my eighth tick mark will be 2 pi, my second tick mark up here was a 1, and there's my -1. I'm also going to come out here and make a negative pi. So what I'm going to graph first, and I'm going to do this in red if you want to color code, that's great. The sine graph. I'm going to graph the 5 key points for the sine graph first. And the sine graph starts off with 0, and then 2 tick marks over we're to the 1, and then 2 tick marks over we're at 0, 2 more tick marks we're at -1, and then 2 tick marks we are at the final part of the sine curve. Now I'm not actually going to graph the sine curve, but these 5 key points are important for the cosecant. What I'm going to do now is do the reciprocal of these values. And similar to what we learned in the tangent graph, if we have a 0, the reciprocal of 0 is an undefined value. So all 3 of those zeros will turn into vertical asymptotes. So we have 3 vertical asymptotes in the first period of the cosecant function. We have 2 values that are left. We have this value of 1, and we have this value of -1. But we remember we need to take the reciprocal of those values. Well, the reciprocal of 1 is still 1, so that's why having this point here is fine. The reciprocal of -1 is still -1, so that's why this point is fine. If you understand that the first part of the sine curve would be going up like this and making a bit of a mountain, please understand then that the reciprocal of all of these values will actually look like this. It's not a parabola, but it's sort of a parabolic shape. And when I go down here, the second part of the sine function is like this little bit of the valley, but the reciprocal of that valley will look like this. And this is the first period of the cosecant graph. And again, you can almost see the sine graph hiding right in here. You don't necessarily need to dot that in, but again, we wouldn't be able to graph the cosecant unless we knew how to graph the sine. I'm going to undo all those. If I wanted to continue this pattern, I see that the vertical asymptotes occur every 4 tick marks, or rather every pi units. So I know that there's another vertical asymptote here. And if I go backwards, I know there's another vertical asymptote here. And then the rest of my curve, I'm bouncing from a 1 to a -1 to a 1. And if I go backwards, I'm here at a -1. And I'll do one more over here with 1. And I can put in as many different parts of the cosecant curve as I want. But like we're practicing in class, I really just want you to graph one period of each of our graphs, which is why I really only want this part, and I'm going to bold this in. I just want the first period of the cosecant curve. So I'm going to bold this in. These 2 parts represent the first period. The rest is just extra graphs. Let's talk about domain and range. Because like the cotangent and the tangents, our domain again is restricted. So it's going to be the set of all x such that we're going to do a first restriction. And I'm looking at my graph, and it looks like my first restriction is actually right here at 0. X cannot be equal to 0 pi. And then how often after that will I have a restriction? It's every 4 tick marks, which in our scales represent pi. So I'm going to say x can't be 0 pi plus pi k. So I'm simply going to say pi k. X cannot be pi k. Very similar to the tangents and the cotangents. When we talk about the range, we're talking about all of the possible outputs, all of the possible outputs. When I'm looking at my cosecant graph, I see that this part of the graph points all the way down. So our range starts at negative infinity. I understand that. But we don't go all the way up to positive infinity because we actually skip a bunch of values here in the middle. The highest we get, at least for this part of the curve, is right here at the top, which is -1. And we're going to stop right there. We get to include it, so I'm going to put a bracket. And then I'm going to union that with another one. We skip a bunch of range values until we get to this piece, which starts at 1 and then continues all the way up to positive infinity. So the other interval is going to include the 1, so there's a bracket, and go up to infinity. Basically, it's the reverse of the range of the sine curve. Remember, the sine curve bounced in between +1 and -1. In this case, we're on the outside of +1 and -1. So there's your cosecant curve. We're going to graph the secant curve very similarly, understanding that this is the reciprocal of the cosine curve. I'm going to do this one in blue. First, let's label our axes. It's very important to label our axes, and we want to stay consistent according to the rules that I've set up in our previous tutorials, where the x-axis will always be the same for everybody, but the y-axis I'll give you a little bit more leeway, though I encourage you to try to stay consistent. The secant graph is the reciprocal of the cosine, so I'm going to graph the 5 key points of the cosine, and those start with 1 and then go to 0 and then to -1 and then to 0 and then to +1. And you can see that there's the cosine curve right in there. I'm not going to actually make the cosine curve because now I need to make the reciprocal of each of these values. I have 2 zeros in the middle of the cosine curve, so that's where my vertical asymptotes will be, because the reciprocal of 0 is 1/0, which is an undefined value. The 2 1s stay as 1s, and the -1 stays as a -1. So the secant curve has this part, has this middle part, and has this part. That is one period of the of the secant curve. Kind of looks like a little sad face right in here. Yeah, okay. So this is really all that I want for the secant curve. And again, you can sort of see the cosine right in here. If you want to dot that in, that's fine. Just make sure it's dotted because that's not part of the graph, but if that helps you. If you want to continue this pattern to see the rest of this curve, that's fine. Again, the vertical asymptotes are exactly 4 tick marks away, so another 4 tick marks here would get me here, and another 4 tick marks gets me to here, and 4 more tick marks or pi units away right there. And I'm bouncing from +1 to -1 to +1 to -1, and over here there'll be a -1 here. So I can do this part of the curve, I can finish this part of the curve, finish this part, and I do a little half part right there. Obviously that's a lot of the parts of curves, so I really only want one period of it, which again is just this half up here, just this half up here, and then this entire curve right here. So I'll bold this so you can see what one period of the secant curve looks like. Let's move on to domain and range. Very similar domain and range. It's a set of all x's such that x is not equal to. I'm looking at, I always start at 0 and I try to get as close to 0 as possible. The first restriction, I could either say positive pi over 2 or negative pi over 2. If they're equidistant away, I'm going to pick the positive one. So I'll pick positive pi over 2. That's the first thing that x cannot be equal to. And now I'm going to add to that the multiple that takes me to each of the other asymptotes, which again is exactly pi. It's 4 tick marks, which is pi. So pi k. So there's our domain. Our range is exactly the same as the cosecant curve. We've got -infinity all the way up to -1, and then we stop. We include it, but we skip a bunch of values in between -1 all the way to +1, so we'll union that with the other interval, which is +1 to infinity. Lastly, I want to talk about the period on this page. Remember, the period for the sine curve is 2 pi. The period for the cosine curve is 2 pi. And that's why the period for both of the reciprocals is 2 pi. The period for both of these graphs is 2 pi. So 4 of our 6 graphs have a period of 2 pi. The sine, the cosecant, the cosine, and the secant. The other 2 graphs that we did in the previous tutorial, the tangent and the cotangent, both had a period of pi. I have one last little note about amplitude. And yeah, okay, that's a very big note. Once again, it does not make sense to talk about amplitude with the secants and the cosecants. Amplitude is the measure of a height, and since these graphs are infinitely tall already, it does not make sense to talk about amplitude. The only 2 graphs of the 6 that have an amplitude are the sines and cosines, because those are the only ones that have a bounded range. The secant, the cosecant, the tangent, and the cotangent do not have amplitude. They will still have a value of a, but we don't call it an amplitude. That is the introduction to secants and cosecants and the domain and range. Thanks for watching this tutorial, and be sure to check in for the next tutorial where we will practice more of the graphs. See ya.